The one thing everyone knows about climate change is that the oceans and plants are responsible for absorbing about half of all the CO2 emissions humans have been responsible for. At least that's how it used to be. That's how it was for the last 30 years. But in the last 8 years, the amount of CO2 absorbed by plants seems to be going down. And in 2023, the plants didn't make any significant reduction to CO2 concentrations in the atmosphere at all. Do you think our plans to tackle climate change might be even more woefully inadequate than we thought? The trouble is, the world's governments have been relying on oceans and plants to remove so much CO2 because although most troubles to do with climate change can be solved by huge amounts of clean electricity, there are some sectors like farming that are very difficult to decarbonise. But even that plan was a bit wonky because there's so much CO2 in the atmosphere now, the temperatures are rising so quickly, the ice sheets are melting so quickly, that if we're to have a survival future, if we're to stop the ice sheets from melting, we need to reduce CO2 concentrations back to pre-industrial levels. It seems the world governments had given up on that idea. They were just hoping to stabilise CO2 emissions and use the oceans and the plants to offset our carbon emissions. Sometimes you see in the news there's a new machine and it's able to extract huge amounts of CO2 out of the atmosphere and all our troubles are over. Well, there are some machines, they're called negative emission technology, or sometimes it's called carbon dioxide removal. At the moment, all of those machines combined remove 4,000 tonnes of CO2 a year. The plants remove between 3 and 4 billion tonnes, so 1 million times more. By 2050, all the world's climate plans involve huge reductions in CO2 concentrations from the atmosphere. If the plants, as they have done for the last 8 years, have started to reduce the amount of CO2 they absorb, maybe we're in more trouble than we think. So in this video we're going to look at how the carbon cycle works with respect to plants, where we might be heading to. Was 2023, where there was no reduction in CO2 concentrations by plants, a one-off? Is that going to be normal in the future? And then we'll try and work out what to do about it. This diagram shows two things. It shows where the carbon is stored amongst the Earth systems, and it shows how the carbon moves from one Earth system to another throughout the year. Everything in yellow is a natural process, and everything in red is affected by humans. So, for example, the total amount of CO2 in the atmosphere is 870 gigatons. A giga is a billion, so 870 billion tonnes of CO2 in the atmosphere. Compare that to the soil, 1,700 gigatons, billion tonnes. Vegetation, 450 billion tonnes. Permafrost, 1,200 billion tonnes. In the oceans, 37,100 billion tonnes. So the oceans will be a video by themselves next week, possibly. But the thing is, can you see, compared to the amount of CO2 already in the atmosphere, the amount of CO2 in the soil and the vegetation and permafrost is huge. If that was to come out over a long period of time acceptably, if it was to come out though, it would make a real difference to climate change. It would make things much worse. And then the diagram also shows how that CO2 is transferred between the Earth systems during the year. So for example, every year the Earth's plants through photosynthesis remove 113 billion tonnes through natural processes, plus another 29 billion tonnes removed because of something that humans have been doing. So then the microbes in the soil that eat the organic material there, they emit CO2 in a process the scientists call respiration, and they emit 111.1 billion tonnes plus another 25.6 billion tonnes because of something that us humans are up to, which we'll cover in a minute. Plus there's net land use change, which really means farming and the effects of deforestation. So for most of this video we're going to be looking at everything on the left hand side of the diagram. So if you look at the amount of CO2 that's in the atmosphere, 870 gigatons, if you look at the amount of CO2 that's emitted back into the atmosphere each year, 111.1 plus 25.6 is 136.7. What is that? 136.7 divided by 870 times 100. So roughly, nearly 16% of all the CO2 in the atmosphere goes through this process of being absorbed by the trees and emitted back out into the atmosphere by the microbes. It's a really big process that's going on, and you can see that again in the Keeling curve. This is this famous curve that shows how CO2 concentrations are increasing over the years, but it also shows the seasonal effects. So most plants, well, most land is in the northern hemisphere, so it has the most plants. You can see that in the spring and the summer, when the plants are growing, they absorb CO2, so CO2 concentrations go down. In the autumn and the winter, the plants stop growing, they stop taking out the carbon from the atmosphere, but the microbes carry on. So CO2 levels go back up. That's everything you need to know then about the carbon cycle. Now I shall explain why in the diagram it shows that humans are having an impact on the amount of CO2 that's absorbed by the plants and then is returned back to the atmosphere by the microbes. And to do that, I shall explain to you the principles of photosynthesis. So in the leaf of a plant there are holes. The air goes through the holes into the leaf. There's water inside the leaf. And when the sun shines on the leaf, photosynthesis happens, it's powered by the sun, and there's a chemical reaction between the carbon dioxide, CO2, and water, H2O, and the carbon and the hydrogen combine to give you a carbohydrate that the plant is going to use to build itself. And that then leaves over the oxygens from from the water and from the carbon dioxide. So the tree returns that oxygen into the atmosphere. So that's how plants give us oxygen. And it sends that CO2 down to the roots. And although a lot of CO2 is returned through leaves falling or through trees dying and lying on the ground and rotting, most of the CO2 that the plants put into the soil are through the roots. And the roots have a symbiotic relationship with the fungi and microbes that live in the soil. And the microbes, they take the carbon that's been put into the soil by the trees, they combine it with oxygen that's in the soil, and they produce CO2. And the scientists call this the respiration. They say the microbe respiration is returning that CO2 to the atmosphere. And how much CO2 the microbes produce depends on the soil temperature. So the warmer the soil, the more active the microbes will be, the more CO2 they produce. If there's not enough water, it slows the microbes down, because microbes don't really move very fast. They rely on water in the soil washing nutrients to them. But if there's too much water, then the microbes can't cope at all, because they need the oxygen, and the water blocks the oxygen. But in that case, sometimes there are microbes that are able to process the carbon, and instead of producing carbon dioxide, because there's no oxygen in the air, they instead produce methane, CH4. And that's why, for example, when the permafrost melts, the soil is waterlogged, so there's no oxygen there for the microbes, but the microbes that process the carbon that's been stored in the permafrost produce methane, which is why people are so concerned about the permafrost melting. And also there's a whole group of plants that are designed to work in soil that's waterlogged, and they produce methane. So for example, one of the reasons that rice cultivation produces so much methane, is one of the major causes of methane in the world, is because the rice is planted in rice paddies, the roots are saturated with water, so instead the stems of the rice, which are above the waterline, bring oxygen down to the roots, and methane returns back up as part of that chemical process. So the diagram shows each year the plants are responsible for absorbing 113 billion tonnes of CO2 through photosynthesis naturally, plus another 29 billion tonnes unnaturally through human impacts. And that's because the amount of CO2 in the atmosphere has increased. So when photosynthesis takes place, more carbon goes into the leaves, so the plants are growing more quickly. And this is a process called greening, and all climate change deniers know about greening, because they're always leaving comments on the channel saying CO2 is good for plants and the plants are growing more quickly. They are growing more quickly. It's not enough to make a difference, but they are growing more quickly. It's worked out that by the year 2100 there'll be so much CO2 in the atmosphere, if we carry on as we are, that plants will grow at 1.4 times more quickly than they do now. Well, this is an interesting question, because imagine you're a cow, you're eating the grass is growing 40% faster, which means it's got 40% more carbohydrate in, because there's more carbon in the atmosphere and the photosynthesis is working more efficiently. But the grass won't be absorbing the micronutrients that cows and humans need any more quickly than before. So things like iron and selenium and phosphorus, and also remember, all of the vitamins that we need comes from bacteria that's growing in the soil. It gets absorbed by the plants. To get the same number of nutrients, the cows will have to eat 40% more. It's far from clear to me that a cow could eat that much. So if you eat beef, unless you eat 40% more beef, you won't get the same nutrients as before. So no one's quite sure what will happen. The 3.4 billion tonnes shown in pink, the impacts of humans, we're quite fortunate that the forests have been able to extract that extra CO2 because of the way photosynthesis works. That 3.4 billion tonnes out of what's that say, 113 billion tonnes being absorbed. What is that? 3.4, I'll have to do the adding up, divided by 132 times 100. So that additional 3.4 billion tonnes that's being removed is only 2.6% of all the CO2 that is removed. So if the amount of CO2 being removed by the plants was to go down by 2.6%, it's quite a small amount, allowing for natural variation, it would stop having any appreciable impact on the amount of CO2 in the atmosphere. So that'll be something to keep in mind for later on in the video. So that's more or less how it all works. The plants absorb CO2 and the microbes return the CO2 to the atmosphere. You can see how important though the soil condition is for the amount of CO2 that gets returned to the atmosphere. Here's a diagram by the United States Forest Service, and you can see in the tropical areas, like the boring old Amazon rainforest everyone's always banging on about, you can see there's lots of trees there and there's carbon stored in the soil. But in the boreal forest, which is this massive forest that goes around northern Canada, northern Europe, Russia, Siberia, the amount of carbon stored in the trees is less compared to the massive forests in the tropics. But can you see how much more carbon is stored in the ground? That's because the land where the boreal forest isn't so conducive to the microbes. It's colder, the water tends to be frozen for longer. So the amount of carbon the trees in the boreal forest are storing in the soil going into the soil at a much faster rate than the microbes can eat it. So that in that case, the boreal forest is said to have a high organic content. And remember, most of the organic substance from the trees is stored in the top 30 centimetres or the top foot of the soil. So it's quite a thin layer, and the more carbon is stored in the soil, the higher its organic content, the better it is, the better structure the soil has, the more resilient it is to things like desertification or erosion. And the more carbon there is in the soil, it's just a sign of how healthy that relationship is. If you have very little carbon in the soil, that's a great concern. So that's something to look out for. Anyway, that's the theory. Now let's look to see what that means in practice. The number one cause of CO2 emissions increasing due to issues related to the land is deforestation. In fact, although we all think about climate change today as burning fossil fuels, until the 1950s, the number one cause of human CO2 emissions increasing in the atmosphere was deforestation. And that means deforestation, the impacts of farming, because if you remove the forest and plant crops instead, the crops, they don't take as much CO2 out of the atmosphere as a normal tree. Their roots don't go so deeply into the soil, so they're not putting so much carbon in. Plus, deforestation is quite often due to mining, where the topsoil is damaged, that precious 30 centimetres of organic substance that stores the carbon, or logging. And even today, the change in land use, which means deforestation, that still accounts for 11% of all of human CO2 emissions. The second thing that's causing a lot of CO2 to go back into the atmosphere are forest fires, and they mean the carbon goes directly back into the atmosphere without having to go through the microbes, and it destroys the trees, so they will stop removing so much CO2 from the atmosphere. None of these models have factored in losses like extreme factors which have been observed, such as the wildfires in Canada last year that amounted to 6 months of US fossil fuel emissions. 2 years before, we wrote a paper that found that Siberia also lost the same amount of carbon. Quite often you'll see in the news and it'll say a certain forest, probably the Amazon rainforest again, has stopped being a carbon sink and become a carbon source. That means a carbon sink is where an Earth system is removing CO2 from the atmosphere, and a carbon source is when the Earth system is adding CO2 to the atmosphere. But that could be one of two cases. Either the trees aren't absorbing so much CO2 as they did before because of climate change, or the microbes are emitting more CO2 than they did before. The second thing to look out for are the impacts of disease. The boreal forest, this great northern forest, stores 1/3 of all the carbon that's in the soil, and in recent years the amount of CO2 it's removing from the atmosphere has decreased by 1/3, and that's because the trees are being impacted by an infestation of beetles that's making them weaker and less able to absorb CO2. And we saw in the When Will the Frogs Die video, the same things happen with frogs, that the climate change is making it difficult for amphibians and for trees to grow, but it's not making it more difficult for the pathogens that cause the frogs and the trees to become ill. Here's something by the British government. Milder and wetter winters followed by increased spring rainfall are likely to enhance the survival and infection potential of many tree pathogens. Hotter, drier summers leading to drought stress in trees will also increase their susceptibility to disease and expand the distribution range for some pathogens. Not only are the trees in the boreal forest being attacked by beetles, but also the trees in the boreal rainforest or boreal forest are adapted to cold weather. As temperatures rise, it makes it easier for trees living on the northern border of the boreal forest to move further into the Arctic Circle, but it makes it more difficult for the trees living on the southern border, so the forest is also moving north. For how much longer it will be able to move north? Will there be enough land there? I don't know, nobody knows, but it is reducing the efficiency that the trees can live. New trees are having to be grown further north, and the old trees in the south are going into decline. Also, the microbes in that area are starting to become more active. If you can see in that diagram how much carbon is stored there, is because the microbes haven't been able to be that active because the ground was so cold. As the ground warms, the microbes are becoming much more active and emitting much more carbon dioxide. The next thing is erosion. 16% of Europe's land is in danger of erosion. And already, if we look at that diagram we did at the very beginning of the video, every year 2.5 billion tonnes are washed away from the soil. One of the impacts of climate change is a warmer atmosphere can hold more water vapour, but the dynamics of water vapour and rain mean when it starts to rain, it will really rain and all the water vapour will come out very quickly. But then it will take quite a while for all that water to build up again, so you have periods of heavy rain and then possibly periods of drought, which is a good way to get erosion. The Mediterranean region is particularly susceptible because it experiences long dry periods followed by spells of heavy rain. In many of these southern areas, soil erosion is already at irreversible states, while in the worst affected areas it has stopped because there is simply no soil left. Too much erosion, or the trees no longer are able to store the carbon in the soil because there's not enough rain for the trees to grow. The trees suffer from water stress. Then you end up with a desert when the trees stop adding carbon to the soil, but the microbes carry on eating the carbon and returning the CO2 to the atmosphere, and the amount of organic material just goes down, and your soil becomes a desert. And in the European Union, I've just found these European stats in one report. I'm guessing it applies to lots of places around the world. In the European Union, 8% of southern, central and eastern Europe are at a very high risk of desertification. Spain, according to some people, has already started that transition to becoming part of the Sahara Desert. So for trees living in the temperate areas, they stop photosynthesis at 34 degrees Celsius. They stop removing CO2 from the atmosphere at 34 degrees Celsius, and they die when temperatures get to about 46 degrees Celsius. Quite often trees will be 4 degrees Celsius cooler than the surrounding air because they live in forests. They all benefit from the shade of each other. So as forests go into decline, as the amount of trees thins out, they get less benefit from the shade and they go into decline more quickly. So there's two things. There's heat stress and there's water stress that trees suffer from, and that's both of them severely reduce the amount of CO2 that they extract. On planet Earth, there are 3 big forests that are being affected both by the direct actions of humans through logging and deforestation for farming or mining, and the indirect impacts through climate change. The Amazon rainforest has been affected by fires, by changing weather patterns. That means since the 1980s the climate has become much drier there, by illegal logging, illegal farming, illegal mining. Why is there so much illegality going on in the Amazon? It's because the people there are very poor. But you may have seen the video last week. The wealthy countries in the developed north are meant to help out developing countries in the global south that are being affected by climate change, and to help them to reduce their carbon emissions. So you might think, well, why doesn't the global north help the poor people in Brazil out so they would stop damaging the Amazon rainforest? Well, it's a good question to ask. The second big forest system to be impacted is the one in Indonesia. And there are 2 things that happen there. First of all, they cut down the forest so they could grow palm oil for the global north. And secondly, now the number 1 cause of deforestation in Indonesia is mining. That's the second big forest being affected. And then the third one is the Congo. And the Congo is being affected by illegal logging. So those are 3 big forests that are having impacts. It was always known that we could not rely on the plants to carry on as they are. Based on model projections under the intermediate greenhouse gas emissions scenario that stabilises atmospheric CO2 concentrations this century at shared socio-economic pathway 2-4.5, that's the one we're meant to be on at the moment, the rates of CO2 taken up by the land and ocean are projected to decrease in the second half of the 21st century. Although, look on the bright side, it is very unlikely that the combined global land and ocean sink will turn into a source by 2100. Here's a long list of the countries that were assuming they could just rely on the plants carrying on as they were. The United States, Indonesia, Thailand, France, Cambodia, Sweden, France, Portugal, Macedonia, Slovakia, Costa Rica, Hungary, Slovenia. 2023 was a different year. It wasn't just part of this general decline. Do you know what was special about 2023? 2023 was an El Nino year, and it was a particularly strong El Nino. And it looks as though an El Nino year, which is where temperatures are much warmer in the Pacific, which affects rain patterns all over the world, affects temperatures all over the world. So in 2023 there was excessive heat in the northern hemisphere affecting the boreal forests. The changes in rain patterns affected the Amazon and other forests as well. Some forests got more water than normal. So in some ways El Nino was just another example of changes in climate change affecting the forests. But on the good side, if there's a La Nina year where temperatures are colder in that part of the Pacific that causes this weather patterns to happen, it's part of the El Nino Southern Oscillation, where you flips between El Nino and La Nina. Those La Nina years tend to be carbon sink years where the plants absorb more CO2, and El Nino years are years where the plants absorb less CO2. In a previous video we saw as the AMOC slows down, the current in the Atlantic Ocean slows down, it will stop taking warmth to the northern hemispheres. That will mean the mid-latitudes will increase in warmth. That will make the El Nino stronger in the future as the AMOC slows down. And that will cause less heat to be taken away from the tropics, which will make the El Nino weather patterns more pronounced. So we could see 2023 so far was a one-off. The next time there's a strong El Nino year, and it looks like they're all going to become stronger in the future, these changes in weather patterns will be more pronounced and the forests will suffer more greatly. The main message is these forests are really important, not because we like being tree huggers, but because they're already reducing, hopefully in a good year, they're reducing the amount of carbon dioxide 1 million times more quickly than even the latest technology which you see in the newspapers claims it will save us. So these trees and plants are really important, and the governments need to prioritise them. Right now, deforestation, fire and logging are damaging forests everywhere, but drought less so. Helping Earth's forests resist climate change means keeping them as intact, healthy and vibrant ecosystems. Boreal forests have experienced a 36% drop in capacity due to disturbances like wildfires, insects, outbreaks and soil warming. If you're a country that's expecting to rely on the forest capturing lots of CO2 so you can carry on farming and still get to net zero by 2050, then you need to do something to protect the forests. But there is some good news, and I know you're going to say, count everything, are you being paid by the Chinese government to make these videos? The answer is no. I just follow the evidence and this is where I end up. In contrast, the carbon sink capacity of temperate forests has increased by 30%. This is largely due to extensive reforestation efforts, particularly in China. Their recovery shows how land management policies and practices can help to preserve this global carbon sink. I'm sure that the world's governments, relying on the trees to help them with their carbon plans, will be only too delighted to follow the good example of China. But the question is though, was 2023 a one-off, or can we expect to see similar things in the future? In the northern hemisphere, where you have more than half of the CO2 uptake, we have seen a decline trend in absorption for 8 years. There is no good reason to believe it will bounce back. This is how things are going to be in the future. So it turns out our climate plans really are woefully inadequate, which is not really a surprise, is it? But anyway, that's the answer. That's pretty much the end of the video. I was going to try and do this one outside because I think the outside ones are more popular, but at the moment there are 50-mile-an-hour winds outside, and there was only one good day to video and it gets dark by 3 o'clock in the afternoon. So we have to persevere with the indoor ones, but at least it means I can do one video a week. When the weather gets nicer, I'll try and go outside again, but it means I should do fewer videos because it just makes it more difficult. But anyway, thank you for watching, and see you next time.